Okay, now we're going to look at protonated amines and their solubility. Okay, protonated amines are soluble in water. Okay, we're going to talk about why they are soluble in water. So we'll just start off by drawing one. Maybe something pretty straightforward, not to take up too much space. Maybe this. Okay, this is the methyl amine, the protonated form of the methylamine, or methanamine. So I probably need to just redraw it so I can actually show you what we're looking at here. Put the positive there. Okay. Let's look at water, and remember that water has got a partial negative charge on the oxygen, partial negative charge on the hydrogen. What that means is that we can have an ion dipole bond occurring there between the positive charge, or the full positive charge on the nitrogen, and the partial negative charge of water. So like what we looked at with the carboxylates, we're looking at ion dipole interaction. Okay, the ion dipole interaction is what renders a protonated amine soluble in water. Okay, because it's quite a strong interaction. Now, the difference between the solubility of protonated form and just the amine is again pretty much the same as the carboxylate ion and carboxylic acids. If we look at the amine, okay, we've got a bit of polarity on the NH groups. Okay, and with our water molecule, I'll just draw it like this. Okay, we can get some hydrogen bonding due to the polarity of water. Okay, but again, ion dipole is stronger than water. Ion dipole interactions are stronger than hydrogen interactions. Right, therefore, protonated form of amines are more soluble. Alrighty? So, you can use this information. Right, if you have got an amine that is insoluble in water and you want it to dissolve, well, you can react it with an acid. Okay, so we just look at our amine. Right, let's say this has got a large molar mass, so this is insoluble. Right, all we have to do is react it in the presence of some acid or an aqueous acidic solution, and we end up with the protonated form, which is soluble in water. Okay, pretty straightforward. When this reaction occurs, it probably actually looks like that the insoluble amine is dissolving, but what's actually happening because of the reaction with the acid, the insoluble amine is starting to form the protonated amine, and the protonated amine is soluble. So it would appear that the amine is actually dissolving, where it's just turning into a protonated form, okay, which is water soluble. Alrighty, catch ya.